Hi, so I'm Chris Ferry, I'm the CTO of StorMagic. I'm going to start off doing a brief introduction to the product, going into a bit more detail, and then do a couple of demonstrations. The demonstrations actually run as videos rather than interactive. It seemed an easier way to do it, so we'll see how that works out. So Hans has already talked to you quite a lot about the product. Basically, what we provide is a software storage stack that runs on a version of Linux that we put together that typically runs as a virtual storage appliance on top of a hypervisor in a virtual machine. We support vSphere and Hyper-V at the moment with our release product. In principle, we can support KVM or Zen as well. We've had proof of concepts running on those. Because you're running a VSA, you're effectively independent of the hardware environment, which is nice. We can work with whatever storage gets assigned to our VSA. So that could be simply disk drives. It could be conventional disk drives or SSDs. It could be a RAID controller, either an external RAID controller or a PCI RAID controller. It could be flash storage, anything we can take. What we generally do is we take the storage that's assigned, well, what we do is we take the storage that's assigned to the VSA and allocate it to a storage pool. So you could have different categories of pools. So you may have an SSD pool for your fast storage and maybe a SAS pool for some other storage or a SATA pool, whatever. We don't care what the storage is. Even in the hypervisor environment, there's different ways of doing it. You can do it in VMware, assigning a VMDK to the VSA. Better way of doing it is if you do it with a raw disk mapping, because then you avoid all the overheads of VMDKs. You can even do a PCI mapping of a PCI RAID controller direct to the VSA if you want, and that's the most efficient way of doing it.
Can you provide a nice SCSI volume to an external server, for example? So instead of working only on the servers of the cluster, can you provide a LAN to an external server?
Yes. So what we do is we take the storage, we basically put it in a pool, and from that pool we create virtual disks. Those virtual disks are exposed as iSCSI LUNs. Anything that talks iSCSI has got access to them. So the typical way of doing it in the environments we're going into at the moment is the hypervisor will basically take the iSCSI LUN, format it up as a VMFS file system, and then use that for creating its VMDKs for virtual machines. If you want, though, you could create an iSCSI target and assign it directly to a guest virtual machine. Or if you want to, you could assign it to some external server, some physical server. We have actually got a small number of customers that are running on, directly on bare metal, so not even as a VSA, but actually directly on a server. And in those cases, they're providing storage, directly to other servers in the organization. So as I say, what we do is we then present the storage up as a iSCSI virtual disk, and you can have as many of those as you've got capacity available. So the way we get the high availability is we do synchronous mirroring between the pair of servers, and I'll talk a bit more about that in the technical section. Because it's synchronous mirroring, what that means is that if one side of the mirror fails, then the servers can instantly fail over and access the storage on the other side. So it's truly active-active. The servers can access either side of the mirror at any point in time, and they are completely peers. And it's because it's synchronous mirroring, that means that any write sent to one side of the mirror is also committed to the other side of the mirror before it's acknowledged, which means that both sides of the mirror are guaranteed to contain the identical data, which means that any failover can be done instantaneously. So I'll now move into the demonstrations.
So when you say they're mirrored, is it mirrored in cache or mirrored on disk, or is it?
It's mirrored on disk.
On disk?
Yes.
No,
that's what he said.
Be bad performance then. So it has to be synchronously committed to the spinning media on the other.
What does that do to latency?
It adds time.
Generally, the latency is just as good as you get with an external SAN.
If you think of it, you're still going to have to do the exact same thing with an external SAN. If you're writing to an external SAN, you've got to wait until it's committed there. So your onboard is going to commit before your off board, but you're talking about the same sort of latencies.
Interestingly, there's been we've been doing a few timings on some systems with VMware recently, where they've been comparing timings, sort of writing locally and remotely, and in some cases seeing better performance writing remotely. So going over a physical network rather than a virtual network. The latencies are generally sort of
typically, I mean, synchronous writing is done across distance, 10 kilometers or longer. These guys are next door to each other.
Yeah,
so the latency
that's right,
would be not too big.
It's really no different than VMware doing or
Just a network
Pernix,
copy, I guess.
so they're right back.
A lot of our customers just use crossover cables on the back. They don't use a switch. They keep it extremely simple.
Yeah.
Yeah, I mean that's a very good use case. You basically just put a dual-ported 10 gig card in each of the servers with direct connections in there. You use one of the connections for your main host connections and the other for the mirror connection.
Use a really short cable so it doesn't take very long to get there.
Those yellow cables, right?
That's right.
Gold ones, maybe.
Yeah.
But Ray, this is a slightly different use case, unless I'm not getting it right. So you're saying you might normally synchronously mirror a SAN across 10 kilometers or something.
Or, metro mirror kinds of things,
right,
so
okay,
it's up
but-
to 100 kilometers, right?
But that's a different use case. That's for like when you lose a site. It's not
The
the
archive
same
solution,
as two boxes in the same data center.
Yeah, but you don't typically synchronize mirrors within a SAN within the same location.
Yeah, that's what I
Why
mean.
would you do it? Yeah, because I mean it's
Exactly.
redundant, high availability
Yeah.
inside the SAN storage itself.
Yeah, but this is
different.
what you need to do with a virtual SAN.
Yeah.
So how does the failover work then? You said you could go active.
Okay, so I'll talk about that. I've got a demonstration section, and then the next section of the talk is going into rather more technical detail on the mirroring. So I'll cover that then.
You're probably also not as worried about the performance for this type of an office as you are for a big data center. Either.
Absolutely.
So
Yeah, but
So
there
one-
are
one
get away with.
no need to be worried about it because you'd size for the latency and IOPS you need. So if it's going to be that same performance to one system, you know it's going to be the same performance to the other. It's not like it's destaging to one disk first and then the other after doubling your latency. I hope not.
Well,
Well, there's one interesting use case. We've got one customer in Europe that they originally put our software in as a temporary measure. They were running some sort of some NetApp servers, and they needed to migrate to some new servers. They put our software in as a temporary measure while they were doing the migration. Once they had actually got it in there, they found that we were actually outperforming the NetApp servers with our using synchronous mirroring across a metropolitan network.
Across the man.
Yeah.
They removed $1 million worth of filers and put in $20,000 worth of software instead.
Yeah.
And do you typically see, I'm guessing you're not seeing very high transaction rates or high bandwidth rates on these mirroring operations?
They're not. Most of the environment we're going into, they're not that high. So, IOPS are, main maximum IOPS are only a sort of few hundred. However, internally we've done our own testing. So, using SSD arrays and so forth, then we can sort of scale up to sort of 50,000, 100,000 IOPS. And then you start hitting limits within the CPU limits and that sort of thing. We're running as a virtual storage appliance. We're running iSCSI, and if you run iSCSI, then the biggest consumer of CPU cycles is the TCP stack. You find something like 70 or even 80% of the CPU cycles go on the TCP stack. So what you find is if you've got very fast networking and very fast storage, then eventually you max out on the TCP stack in the software. Now the nice thing is, because we are a purely software solution, you can start getting over that by adding extra cores. So our minimum configuration is pretty low. We can run with a single CPU core and 1 gig of memory, and we provide adequate performance sort of for our target market. But if you need to go to higher levels of performance, over 100k IOPS, then you can put SSDs in, you can put 10 gig in, allocate sort of 2 or 4 cores to our VSA, and you can start delivering those sorts of throughputs. Okay, so for the demos, I've got them as videos, so I'm going to have to drop out of this for a moment.
So just to be clear, the data on a single server is not RAID protected. It's mirrored.
Typically it would be. So typically, if it depending on the capacity they have, a lot of our customers would actually have a RAID controller underneath us, and that would take care of any disk failures. It would actually be the typical configuration. In ways it's overkill, because they could avoid having that. They've got synchronous mirroring. If they lose a disk drive, they can fail over to the other side. But typically we find they do have a RAID controller underneath us.
And with synchronous mirrors, both, they're active, so you could be writing to either server for that virtual disk.
Yep.
We had this discussion earlier.
And we'll probably have it again.
Environment, yeah.
Slightly.
Slightly.
Okay, so in the first demonstration, I'm just showing some provisioning in an ESX environment. So I'll start the video playing and hope that it plays at the sort of right rate for what I'm talking about. So what we've got here is we've got a StorMagic plugin to the vSphere vCenter client. And within that, I've got an option where I can, actually, I'm going to just slow that down slightly.
Is the web client compatible yet?
Yes, we've got a version for the web client. The web client's so crap we didn't bother to share that one. Sorry, I've heard so many bad things about the web client, and we've talked to so many customers, and nobody seems to like it. We've done the work, so we've got a plug-in for it. It's using Flash technology, which VMware say you should be using, which seems to be obsolete now. And, so anyway, we've got a what we've got is a plugin. This is for the .NET client, but we've also got one for the web client. It just appears as a StorMagic tab in there, and within that we've got an option to create a data store. So if we select that option, then it starts a wizard up. You select the VSAs that you want to use for the mirrored data store. You give the data store a name and select a size that you want for the data store. This is 100 gigabyte one. Click next. Now we need a quorum device in there. I'll talk about that more in the next section. But you select the quorum device, and then you can select the vSphere host that you actually want this storage to be provisioned to. So we've got 2 hosts in this particular cluster, so we're doing that. We then click finish, and it will go off and start doing it. So the first thing it does is it creates the mirrored data storage across the pair of VSAs. So basically allocates some space support for them, sets up an iSCSI target. It will then set access control to that iSCSI target so that the vSphere hosts that have been assigned to use that target have got access to it. Once that's done, we then integrate with the VMware environment, the vSphere environment, and we talk to the ESX hosts. We get them to discover the new iSCSI data store that we've created. So we do the iSCSI discovery. We then do the login to that data store. Actually, there's one other step. If you look at the bottom of the screen, what you can see is the various operations happening. So once we've added the targets, we initiate rescans on the ESX host, so they actually see it. Then we do the login. Final step, which is happening there now, we create the VMFS data store. So at the end of it, you've got a new data store that you can use for creating VMDKs or whatever. And I think the last part of this demo is actually going to show sort of creating a new virtual machine on that data store. So it's truly end-to-end provisioning. It's not like creating an iSCSI target with one tool, do something else with another tool. It's all fully integrated.
So maybe I missed this. Did you say that there's basically a set of disks on both sides where it's creating a single data store?
That's right. So it's creating a single mirrored data store. Right. So it basically creates it on each side, and it then does a resynchronization of the mirror. So basically it copies everything from one side to the other to make sure that both sides are initially identical.
Okay, and is there like a witness disk or a quorum?
Yes, that was actually early on in the demo where we set with the witness the quorum. It's not a disk, it's a service, and I'll talk about that more in the technical section as well.
Do the storage environments have to match between the 2 servers?
No.
So one could have SSDs and one could have 5400 RPM disks and stuff like that?
It could, but that wouldn't make sense. That would go against best practices. But we don't actually restrict that.
It would just go at the slowest speed.
Yeah, exactly.
I assume
But you could have that, and you could set your paths to.
You could set your path policy to. But when you're writing, then it's got to go to both sides, so it's going to write at the speed of the slowest disk. So you can do whatever you want. The servers don't have to be identical. They don't have to have the same amount of storage or anything. Obviously, the size of the mirror you create, you have the same amount of storage on each side. But if you don't want, if high availability isn't important for certain of your targets, you can create simple targets which aren't mirrored as well.
I'm sorry, you can create a non-mirrored target?
Yeah, yeah. They'll have no high availability. You know, if a VSA is hosting a non-mirrored target and that VSA goes down for any reason, that one will go offline. Yeah. But you know, you may have some virtual machines that are running non-critical applications where you don't care about that. So that was just really to give you a flavour of sort of, you know, the interfaces and so forth. The next demo I've got actually shows a failover. So what we've got here is we've got our pair of servers. It's quite difficult to see that on the screen, isn't it? So we've got our pair of servers. We've got a number of virtual machines running in them. And what's going to happen here is that one of the servers is going to be physically failed. So behind the scenes, they've pulled the power on one of the servers. So basically, vSphere will see a problem with the server. Very difficult to see those messages. And the VSA running on that server will fail, but everything else will sort of continue running. Any virtual machines that are running on the failed server will get failed over by VMware in the normal way, and the storage remains online throughout the whole operation. So you can just about see there, it's, you know, reporting things as not there. What we'll look at the end of this, I think just coming up, is we'll go into our actual console where you can see the state of the mirror being reported by our software.
So there's a question from Twitter. How is StorMagic solution different from a 2-node plus FOM left-hand VSA setup?
There is no such thing as a 2-node left-hand setup. So you always have to have a third node with left-hand.
For
that
left-hand?
could be a desktop PC in the office, theoretically. Theoretically.
Correct. So but you have to have something locally. So Chris is going to go into detail later on how our quorum service works. In the case of left-hand, you must have local quorum because their actual latency requirements don't allow it to be remote, and that's the key difference to us. So typically, in the case of that large customer with 2,000 locations, their quorum service, as Chris will explain how it works, is actually central in the data center. They don't need to have that third node on site. That third node adds cost and adds complexity.
We have actually won business competing against VMware's HP's Store Virtual for those sorts of reasons.
Well, our biggest partner is HP. Maybe that answers the question better.
So I'm just going to skip back to the end of that one. At the end of it, we're showing on our own GUI the actual state of the mirror. So it's gone again. So you can see that it was reporting one side of the mirror as unsynchronized.
And when the failed host comes back up, at that point, does it say it's like resynchronizing before it starts writing?
Again, I'll talk about that more in the technical section.
Okay.
The third demo I've got here is our bare metal recovery feature. So this is a nice feature. What this allows you to do is recover from a complete server failure. So remember, we're targeted at distributed organizations. They've got a pair of servers at the remote location. Sometimes they're going to get a physical server failure. When that happens, what they want to do is they want to replace it simply. They don't really want to send anybody out on site to do anything. You know, ideally, they want to do it all remotely. What our bare metal recovery feature enables them to do is basically ship out a replacement server with ESX installed on it. You don't need anything else installed on it. Plug it in, and then they can remotely run a recovery wizard, which will basically regenerate the failed virtual storage appliance on the replacement server. So the way this works is when we've got a pair of servers out there, we mirror all of the configuration data between the pair of servers so that when you do the replacement, we can deploy a new VSA out there, simple OVF deployment, and then we can automatically configure that new VSA with exactly the same configuration as the failed VSA. There are options for changing things if you need to, but basically the failed VSA gets created exactly as it was before. Any of the mirrors that existed between the pairs of VSAs get recreated, and then they get automatically resynchronized. So at the end of the operation, you're back up and running with full high availability, full redundancy, with minimal effort for doing the replacement. trouble is you can't see, you can't actually see what's happening very well on the because of the screen resolution. So what this is showing at the moment is the deployment of the replacement VSA. So just kicking things off. The replacement server doesn't have to be identical, so you could be replacing it with a different model. It needs to be at least as good. It needs to have at least as many network interfaces available to it and at least as much storage available to it. But otherwise, it could be something completely different.
So if you decide you need to upgrade,
you could use
fail one, put the new one in, fail over, and
you could, yes. And that is one of the use cases that's come up. Some people quite like it for that.
I mean, if you think of, as I mentioned earlier, that customer of ours, the big customer of ours, they want to change server manufacturer through the lifetime of the project, a couple of years into the project, you're not going to get the same sort of model server available, even if you stuck with the same manufacturer, and it makes it a lot easier for them.
Okay, I'll just skip that one and move on to the last one. The last one is showing our dynamic migration capability. So what we've got here is we've got a virtual machine that's running on, we've got a pair of servers, we've got some storage on one of those servers. In this case, it's actually a simple target, not a mirrored target. And we've got a video playing off that mirrored target. What the migration capability gives you is the ability to dynamically move the target from one VSA to another VSA. Now, this also works with mirrored targets, so if you've got a mirror between a pair of VSAs, say A and B, then you could move half the mirror from B to C, so you could go from A and B to A and C. What this is aimed at is part of a scalability story, so that if you want to start with 2 nodes and want to add extra nodes in, then you can start migrating things around from your existing nodes to new nodes. Alternatively, if you want to decommission servers, then you could migrate everything off the server that you're decommissioning onto existing servers and then just get rid of the old server. And you can do that with no downtime.
Is there anything in the pipeline, and I appreciate this would need cooperation across multiple vendors, but to be able to migrate to different VSA platforms?
I'm not aware of anything being done by the vendors, but of course you've got features like storage vMotion, so you can do things like that way.
Is vCenter required to run this?
No.
So you could use the free versions of ESXi?
You could, and we've got customers that do that, yeah. So what we've got is, our VSA itself, as I say, it runs in a virtual machine and it can run on anything. It can effectively run on any hypervisor. We've got our own management interface to that. Well, we've got a variety of management interfaces to that, in fact. So we've got a web GUI that basically effectively does point management of VSAs, although it will create mirrors between pairs of VSAs and that sort of thing. And you can do everything with that if you want. You can create your iSCSI target, set all the characteristics of the iSCSI target, and then go off and use whatever host software you like to connect to those iSCSI targets. If you want to use our integration software with VMware or Hyper-V, then what our VMware integration software gives you is this end-to-end storage provisioning. So instead of saying, create me an iSCSI target and then going off somewhere else to do something, we do it all. The other thing that our integration gives you is it means that we can report events up through the vCenter, so they appear in the tasks and events appear in the normal way. Okay. So that's the end of that demo.
For backup and recovery, are you typically recommending customers back up the VMs that are contained within your VSA or your VSA itself?
We don't recommend people back up the VSA, just the VMs. We're taking care of our VSAs. As I said, our bare metal recovery feature means that we've got all the configuration of one VSA stored elsewhere. We have got an option in there, so you can actually take a backup of the VSA configuration if you want as well. So we're taking care of that. Now, what the customers are doing is they are looking after their application data and backing it up. And although we've looked at doing things like sort of remote replication, it's something we could do. Doing that at the VMFS data store level doesn't make a lot of sense because the recovery of the data gets quite complex. If you're backing up a VMFS data store, then to get the data back, then you have to take the copy of the data store, import it onto an ESX host, and then import the VMs, and it's quite an involved procedure.
Does VMware snapshots and those sorts of things work with this? And all that?
Fine. Yeah, it supports all VMware features because we are just iSCSI storage like any other iSCSI storage you could use with VMware.
So you could use VMware replication if you wanted to?
Yes, and some customers do that. Now, you mentioned vVols earlier on. Obviously, things start changing with vVols because with vVols you are providing the storage directly up to the virtual machines. So then you've got a better capability of doing things like remote replication. So I think really the time to bring in remote replication features is as part of vVol support.
Hey, you mentioned earlier that HP were one of your biggest partners or your biggest partner.
Well, the biggest site we've got are using HP servers, so we went in there with HP.
Site, yeah. I'm assuming it's an HP account. Mm-hmm. Why did they use your technology instead of the left-hand Store Virtual?
Because Store Virtual required 3 servers, so they looked at doing it in different ways. They looked at running on 3 servers, or they looked at running on a separate piece of hardware as being that third quorum device. They actually were considering running on their video server, but they had a situation a couple of years previously where someone had been murdered by an implement that had been bought within that store. The police came in, removed the video server, and they suddenly realized if this happened again, they lose everything that's within their store because the quorum device is now gone. So they said, no, it has to be an independent quorum device that doesn't have another task. That implied they had to put a third lump of hardware in there. The physical cost of putting in that third lump of hardware was more expensive than running it.
Right.
We've talked about storage a lot at the edge. What about data protection? Is that totally separate? I mean, they've got to protect that data somehow.
Backup,
recovery,
yeah.
Disaster recovery.
Yeah, and as I say, backup disaster recovery is better done at the application level or the level of the guest VM. I mean, in a VMware environment, we are going in at the VMware data store level, which has got data from a number of VMs formatted up as VMDKs.
What are some of your larger customers doing as far as that goes on the edge like that? Are they replicating to the primary data center? Are they doing individual backups in the locations? What are they?
Well, this is what's interesting. We've looked at this, and there is no consistent story. It's almost like every customer you talk to, they're doing something different. So, quite a number of the customers, the applications they're running in the stores are, possibly homegrown applications, or, in some cases, applications that have been around for quite a long time, and they built the backup, the data, data protection into those applications. In other cases, they might be using sort of other products like sort of Avamar, for example. One of our customers is using, they've got different products in there.